Hello everybody, this is Tony, and I do stuff. I'd like a corn dog, but my toaster oven doesn't want to cooperate. Let's fix that. I don't believe the problem is the toaster oven because my can opener doesn't work, so it's plugged into the same outlet. This is a ground fault interrupt outlet, and it's there to protect us in case something goes wrong with the outlet or something goes wrong with the circuit. Here's my disclaimer, folks. I am not a qualified electrician, so don't take anything that I say to be absolutely correct. I'm just a guy that likes to fix stuff. So hopefully I won't give you any bad information. Ground fault interrupts are placed in areas where there is a high probability of electric shock. As with my installation, it's in the kitchen, over here on the counter side where there are outlets and a sink. These outlets are installed in an area that is in very close proximity to the sink. And this is a place where you could accidentally knock something like your can opener over into the sink and put yourself in jeopardy of getting shocked. In my kitchen, there is an outlet on this side where the sink is, but it has not been affected. I guess it's too far away. I'm sure there's some standard measurement that the OSHA or NEC requires to have a GFCI. And on the other side, I have two outlets, and they have not been affected. These three outlets are likely slaved to that GFCI. To verify my circuits, I have a small unit that you can purchase at any home store. Probably get this thing at Walmart. But it's a circuit tester that makes it easy for you to test these outlets to see if they work. First thing you do is always put it in a known outlet that is working correctly. And this one does indicate correct. I have already tried pressing the test and reset buttons, and I get no reaction. As you can see, plugging the little tester in, no lights. And as suspected, the other units that I think are slaved to this GFCI are also dead. GFCIs are in the electrical section at most stores. I got mine at Home Depot. You can get it at Lowe's. This is a 20 amp unit. I think I paid about $26 for it. So it's not very expensive. And everything you need is in here except the tools. The kit comes with the GFCI unit itself, instructions in several different languages, and some cool little label plates that you're supposed to stick on the outlets when you're done. Pay particular attention to the markings on the back of the unit. For instance, this one says the hot wire goes on this side, and this screw is golden in color. The hot is black, usually in the United States. Well, it is black in the United States if it was wired correctly. And the white wire is the neutral, and that goes on the silver screw. Also, very important, there's the ground screw or the bare wire that you'll find in the outlet. And this label plate here is for the slaved outlets. So you put your power here, and then you connect the other outlets that are slaved to this unit to these two terminals down here. And they put a label plate over that so that you know that's what it's for. In addition to what comes in the box, you'll probably need a set of electrical snips, some needle nose pliers, a standard screwdriver, the aforementioned electrical tester, or if you're a little more advanced, an electric multimeter. Now, the GFCI is not magical. It does not protect against overloads or shorts, and you can still get shocked. What a ground fault is when the normal flow of current decides to take a different path. And this can happen if your appliance is defective or if you knock something into the sink such as the can opener, this could set up a condition where you could get shocked. But the GFCI is not going to keep you from getting electrocuted. It's just going to protect the circuit and stop the flow of current when a potential hazard does exist. Okay, with all that stuff out of the way, let's get started. First thing we got to do is make sure that there's no power to these outlets. My breaker panel is located in the garage. Most boxes have some kind of a legend that identifies what the breakers are. If it's like any other box I've ever looked in, the handwriting is atrocious, but you can make it out. My box says that the kitchen GFI is on breaker number 12. We look over here at breaker number 12, we'll see that there's a double breaker in here, and it is the top one. So we will turn the top one off. Okay, remember, just because you turned off a breaker that said kitchen GFI, don't bank on that. You don't know if the electrician that wrote that legend did it accurately. He could have got confused. So always test. We're going to use this unit as well as the multimeter, and I'll show you how that works. Let's try it on a known good unit first. Something we know is live. And then we'll go to our units that we think we've shut off, which we knew were dead. Yep, nothing there. Nothing there. To the suspected GFI itself. Okay, let's go for it. If you're using a multimeter, you need to set it to measure AC voltage. That's this V with the little sine wave there. I'm going to insert the probes inside the two little slots there, and you can see we have 123.4 volts on this outlet, so we know the meter works. We will perform that same test on the suspected GFCI, suspected faulty GFCI. Yeah, we're going to probe around in there, and we get nothing. Can you guys see that? There we go. 0.256 and fluctuating. That's essentially nothing when you're looking for 120 volts. That's too big. Like I said before, I am not a qualified electrician, so don't believe anything I say. You're doing this at your own risk. Okay, we're going to bend this puppy around so we can get access to all these wires and figure out where they go. Now, once again, just because we tested the slots in the outlet doesn't mean we're not going to test the actual terminals to see if there's any power here. So we're going to go to here, which according to the legend on the unit is the line. That is the power coming into the unit, and these two are going to the outlets that the GFI feeds and protects. And we have no voltage on either one. Even though I have tested this and it is apparently safe to touch these terminals, I'm still not going to go out of my way to come into contact with one of these. Okay, so be careful. To keep from getting confused, I'm going to put the live circuit on my right and the outlets that are being protected on the left. You guys remember that in case I forget, okay? Okay, the new unit says the line or the hot wire is over here. And remember, that is the gold colored one. So this wire goes here, and the neutral, which is the silver screw, is the white lead, and that goes here. Now there's two ways I can do this. I can either loop the wire around, or I can just go through the little slots. I'm going to choose these little slots right here. It turns out that the wires, the insulation that stripped off the original insulation was a little long, and even when that wire's bottomed out, I've got a lot sticking out here. So I'm going to snip off just a little piece of this so that it seats better. All right, now that we got all the wires hooked back up, we're gonna shove it all back in there. Now this may be a little tough because some of those wires are pretty thick, but if you work with it, you can get it done. Okay, that's done. Now let's go turn the power on and see if all this works. This is the part that always scares me. I'm waiting for my wife to scream or the breaker to trip. All right. Okay, we've got the breaker on. Let's hit reset and we've got power. Let's check our other outlets. All right. All right, I can taste that corn dog already. Looking good. And no job is finished until you do the proper paperwork. So documentation, we've got to put these cute little stickers on here. Out with the old and in with the new. Oh yeah, that looks official. Woo. Oh yeah. Oh yeah. That hit the spot, folks. The installation was a success, but it wasn't without a glitch. If you look at the video really close, you'll notice that the Leviton terminals and this made by Pass and Seymour Incorporated, the load and the line terminals are reversed on these two units. I didn't notice that, and I tried to wire it using the ground terminal as a reference. Bad move. Anyway, nothing happened. Turned the breaker on. Outlets were still dead. So resort to the troubleshooting guide. Always read the instructions. And the troubleshooting guide said, hey, you've got your line and your load reverse. Pulled it back out of the wall, reversed everything. Things work now. I've got my corn dog. Anyway, hope you enjoyed it. This is Tony, and I do stuff. I eat corn dogs.